So we know that this is a u-shaped function because of the x squared being u-shaped, okay? It has a minimum at x equals minus 2. So what we can do there is we just move this along here, and now we know that it has a minimum value at minus 2. Okay, minus 2 something. Now, when you see the word minimum, what do you think that means? How do we calculate a turning point again? What's the first thing we did to calculate the turning points? We differentiate once and we put the answer equal to 0. Okay? So differentiate once. And when you differentiate once, what happens here? X turns into 2x, b plus b, c disappears, and the answer has to be 0. Now, we've solved this answer already because it's already given us the answer. The answer is x equals minus 2. So therefore, if we replace x with minus 2, it should balance. Because remember, we used to differentiate, put it equal to 0, and then we find the x point. It's already told us what the x point is. Okay? So what we're going to do is we're going to do 2 times minus 2 plus b equals 0. Okay? Now, if you aren't understanding it, remember what dy dx means. The dy dx means the slope, doesn't it? And the slope at the minimum point has to be equal to 0 because it's going straight across. We're told that when we use an x value of minus 2, the slope has to be 0 because it's a turning point. So this is the formula for the slope. The slope is equal to 0. What is the x value we're given? We're given that it's minus 2. Put it in. Minus 4 plus b equals 0. b equals 4. Right, that's your first piece of information. We now know what b is. B is 4. So what we're going to do next is we're going to rub this out. And what we're going to do is we're going to replace b with 4. So b is 4. So the equation now becomes f of x equals x squared plus 4x plus c. Does everybody understand what I did with the b? Yeah. It's 4, okay? Now, it says there's another point on this line. When x equals 3, the y value is? So, by that logic, when I replace x with 3, the answer has to be 25. Okay? So put in 3 here, 9 plus 12, 21. 21 plus c is 25, sorry. C therefore is 4. So it's going to be x squared plus 4x plus 4. Because b equals 4 and c equals 4. Okay, let's try 2 or 3 more of these, okay? Let's see if we can get the hang of them. Yes, Sean?
How come when you get your final...
Question 20. Now, the thing about question 20 is, lads, that what Sean was asked me earlier on is, why doesn't the x value say the same? Do you remember you were drawing the graphs and you got you got cubic functions, you got u-shaped functions, and the x values kept changing all the time? That means that the x values haven't got anything to do with the equation itself. Okay? But you can use values to find out what a is, for instance. So, let me give you an example, right? If you wanted to, the minute you see the word turning point, okay? When you see a turning point, what's the first thing you need to do? Differentiate and put your answer equal to 0. That gets you a lot of marks. The word turning point means differentiate, put it equal to 0. Okay, so let's do that. Differentiate, we'll call it y equals x cubed plus ax squared plus 2. Differentiate, what you get, Sean?
You get 3x.
3x squared, yeah.
Plus 2ax.
Plus 2ax. Plus nothing. Okay? Now, if this is a turning point, what is the slope going to be equal to? For any turning point, the slope always goes straight across, which means it's 0. Okay? That's why we do dy dx equals 0. Remember, we've always done dy dx equals 0 to find the x value. Now, in this case, once again, it's already given us the x value. So what do you think I'll do with the x in this equation? Sub it in. and it has to equal 12 plus 4a equals 0. Bring the 12 over to your side. 4a equals minus 12, a equals minus 3. You now know what the a value is. Is that everybody alright with that? You know what the a value is. So look what happens now, okay? So you know what the a value is. So a equals, what did I say was minus 3? Now you rewrite your equation as f of x equals x cubed. A gets replaced with minus 3. This is your equation, okay? Now, it asks us to find the coordinates of the two turning points now. We want to find the coordinates of the two turning points. Any idea how we're going to go about doing that? How did we do them in the last night's homework and the homework before that? Differentiate once, and what you get? Yeah. And then it has to equal? First derivative equals 0. Remember, f dash x is the same thing as dy dx. Okay? So, differentiate it, and what do we get? 3x bracket, yeah, equals 0. X minus 2 equals 0 or equals 0. X equals 0 or x equals 2. So 0 and 2. Now, next thing is it wants me to find the y value. So, any idea how to find the y values? 0 something and 2 something. Any ideas? Calculator. And you're going to go for x cubed minus 3x squared plus 2. 0 and what's it? 2. 0 to 2. Step of 1. 0 to 2 is the first one, and 2 minus 2. 0 2 and 2 minus 2. Finally, sketch the graph. How do you sketch the graph? You go back here, and this time you start at, I don't know, minus 3, end at 4. And you have to draw a graph of all the dots here. Do you see it? Would you use minus 3, 52? No. Way out of the way. Minus 2, 18 is okay. Minus 1, 2 is good. 0, 2 is grand. 1, 0 is grand. If they're close to the x-axis and x and y-axis, they're easy to draw. And then 2 minus 2 is grand. 3, 2 is grand. 4, 18. No. It's okay. It's close enough. You draw that, okay? Now, asked about, excuse me. I was asked about the limit on how to draw this, okay? So, when you look at your numbers here, you can see that you can have you have 418, and you have minus 2 minus 18, and then you have minus 352. If you look at this graph here, you can see that this region in here is easy enough to draw. If I even go down as far as let's say 18 there. Wait. So you can see plus 18 would be here. Once you get both turning points, I think you're good. So to draw a sketch, you need to make sure you have both turning points. And once both turning points are done, you could then, I suppose, just draw it all the way down to there and be done with it. Because once you have both turning points and a bit of the exit done, do you know what I mean by the exit? The exit after the turning point, that'd be the exit. And then you turn the other one, then you're exiting the other turning point. Once you have that much done, you can see both turning points clearly and the sketch is effective. However, if you were to only take half of it, so an example would be if you were to only draw, as an example, if you only draw that bit, like that wouldn't be a good sketch because it doesn't encompass both turning points. Does that make sense, lads? You just want to make sure that you have both turning points done, not just one of them. Alright? Now, okay, 1 second. If you're asked if you weren't to use your function in the calculator and you wanted to find out how did you get these 2 points here, you go back to your original function, and in your original function you have to sub in x equals 0 first. So minus 3 something, oh sorry. So your function is whatever x is, you put it in, and then you find out what your y value is. So for the first one, it's going to be 0 cubed plus 3 0 squared plus 2. It's 0 plus 0 plus 2. The answer for the y answer is 2. And then you repeat the same procedure for the second x value, which is 2. So you get 2 cubed, which is 8 minus 12 plus 2. 10 minus 2 is minus 2. And that's where we got the second answer from. Is that okay?
Yeah.
Good. Okay. Now, 21. Verify that x equals minus 1 is a root of the following equation. What does a root mean, guys? Okay. Let me just give you a bit of a... Huh? Okay, not that. That's what it could mean, but it's not that. Okay. What a root is, lads, is this. Okay. A root of an equation. If I had an equation, I'm going to make a really basic equation up. Okay. This equation here, x squared. I don't know. X squared minus 6 plus 1x. Okay. If I drew that function, what happens is when I draw this function, it crosses at two distinct points. It crosses at x equals 2. It crosses at x equals minus 3. Now some of you guys are telling me, how do I even know that? Okay, I know it's a u-shaped function because it's an x squared, not a minus x squared. Second thing, what are you guaranteed about any point on this line? What are you guaranteed about any point on that red line? The y value is always 0. So therefore, this gets replaced with 0, and you're then asked to solve this equation here. What is the answer for this equation? The answers are also known as roots. Roots is where your graph goes through your x-axis. What did I just say? Roots is where your graph goes through the x-axis. Okay, so what we have here is x squared plus 1x minus 6 equals 0. Reference number of minus 6. So you're going to get an x minus x plus 3. X minus 2 equals 0. And then you're going to get x equals minus 3. X equals 2. These are the roots of the equation. Now, what this also means is, we now know that my two answers are x equals minus 3, x equals 2. Excuse me. What effect does this what effect do these answers have on your equation? The effect they have is that when I leave x blank like so, and I decide on what number I want to put in, if I put in either 2 or minus 3, what will happen? You'll get 0 equals 0. They'll cause the equation to balance. So if I put in 2 here, I'll get 4 plus 2 minus 6. 6 minus 6 is 0 equals 0. That's what roots do. When you replace x with the root, it causes your equation to balance. Does everybody got that? That will always happen. Anytime you're given a root and you put that root in place of the x letter, it will cause your equation to balance. Now back to the question we're doing currently. Okay? What we have here is we're told that x minus 1 is a root of this equation here. So what did I say is the way to do this? What do you replace x with? So you replace x with what, guys? Minus 1. When you replace it with minus 1, what has to happen? Minus 1 plus 9 minus 15 plus 25. Is that right? Oh, sorry, that's minus 9. The second one's minus 9, excuse me. And what happens is that's minus 25 plus 25. What's minus 25 plus 25? 0 equals 0. We're going to stay with this question, then you can have a break, okay? Now, next question, next part, okay? The diagram shows the graph of the function fx equals x cubed minus 9x squared plus 15x plus 25. There are turning points at C and D. The curve intersects the x-axis at A and D, and the y-axis at B. Find the coordinates of A, B, C, and D. Let me show you what to do here. Okay, let's pick up some easy marks starting off. Now, the best way to do this, guys, is what we're going to do is I'm going to find out what B is first. Can anybody tell me what's the x value of B? The x value. X value is 0. So, therefore, if this is the function, what happens when you replace x with 0? 1 second, Sean. When you replace x with 0, what happens? 0 cubed minus 9 times 0 squared plus 15 times 0 plus 25. 25. B is the point 0, 25, okay? Now, next thing. You're asked to find the turning points, aren't you? You're just asked to find the maximum turning points, isn't that right? So, when you're asked to find a turning point, which is at C, do you differentiate for turning points? If it says turning point, how many times do you differentiate to find the turning point? You differentiate once to find the point. You differentiate twice to see if it's a maximum or a minimum. Perfect. Okay. You differentiate once and you get 3x squared minus 18x plus 15. If x is to the right of the y-axis, is it going to be a positive number or a negative number? Has to be your positive number, so your negative number won't matter if you get one. Okay? Divide by 3 and what happens? X squared minus 6x plus 5 equals 0. Once you're done with that, x minus 1 and x minus 5 equals 0. Is that right? Oh, wait. Okay. So, x equals 1 and 5. Oh, I understand this now. This one here is your maximum point, and this one here, minimum. So, it's very easy to figure out that what it is going to happen is you're going to have x equals 1 and x equals 5. Now, the really easy way to accumulate a lot of information about this graph is like this. Go to your calculator now, put it in, x cubed minus 9x squared plus 15x, you looking? Plus 25. Now, it is 22, you're right. Thank you. Plus 25, okay? Now look what happens here. What numbers do we want when we go back up? We want a minus number. We don't know what this minus number is. So let's take a healthy minus 6 or minus 7. We don't really know yet, okay? So let's go for minus 7. Make it large. We know that this x value here is what, guys? The x value is 5. The local minimum happens at 5. Go as far up as 5 or 6. Now let's look at your points here, okay guys? Look at this. No. Our first point has a y value of what? What does A have a y value of? 0. So look for your first 0 on the right hand side. There is there. Your A value is minus 1, 0. Go again. We already stated that our B value is 0, 25. Let's see if that's the case. 0, 25. Done. We know our maximum point occurs at x equals 1. So our maximum point will be 132. Our minimum point is when x equals 5. Therefore, go along until you see x equals 5. 5, 0. As expected, it's on the x-axis. Okay.